Good morning, everyone. My name is Ruchita and I am from CSE AIML Section C branch. So, the subject name is Matrices and Calculus. The name of the topic is Riemann sums. So, let's start. Introduction to Calculus. Calculus is the mathematical study of change, differential calculus, and accumulation integral calculus. Integral calculus focuses on evaluating total quantities such as area, volume, and accumulated change. Riemann sums from the basics for understanding definite integrals. Riemann sums offer a systematic approach to approximate integrals, linking discrete summation with continuous quantities. Motivation. Area under a curve. The primary objective: calculate the area under a curve y is equal to fx from x is equal to a to x is equal to b. Direct computation is often challenging. Approximation methods are essential. Riemann proposed dividing the area into small rectangles to approximate the total area. By summing up the areas of rectangles under the curve, we obtain a practical and intuitive approximation of the integral. Definition of a Riemann sum. Sn is equal to Ni is equal to I f of xi into delta x, where a comma b is equal to integral of integration, n is equal to number subintegrals, width of each rectangle, function's value at a chosen point in the subinterval. Each term represents the area of a rectangle, width, delta x, and height f into xi star. Summing all terms gives the approximate total area. Partitioning the interval. Dividing a comma b into n equal subintervals. Width of each interval. Smaller delta x or larger n, more accurate approximation. Refining the partition increases the precision of the Riemann sum, approaching the exact value as n gives rise to infinity. Types of Riemann sums. Left Riemann sum uses left endpoints. Right Riemann sum uses right endpoints. Midpoint Riemann sums uses midpoints. The difference in these methods lies in selecting the height of rectangles, which affects accuracy and estimation. Left Riemann sum. Height of rectangle. Left endpoint. Typically underestimates for increasing functions. Left endpoints are simple to implement but may not always give the most accurate estimate. Right Riemann sum. Height of rectangle. Right endpoint. Typically overestimates for increasing functions. Right sum complement left sums and can be combined for error analysis. Midpoint Riemann sum. Height is equal to value at the midpoint of each subinterval, provides higher accuracy than left or right sums. Midpoint sums tend to balance overestimation and underestimation, making them preferable for precise approximation. Example problem. Here is an example problem about Riemann sum. So, the function is f of x is equal to x into 2. Interval is 0 to 2 and in a closed bracket. Subintervals is 4 and here is delta x and L4 values. We get it as is equal to 1.75. This demonstrates the computation of the left Riemann sum increasing n would produce a more accurate estimate. Next, graphical representation of the Riemann sum. Rectangle's approximate area under y is equal to x into 2. Increasing number of rectangles improves accuracy. Graphical visualization helps in understanding how partitioning refines the approximation. Limit of Riemann sums. Taking the limit as n to infinity converts the sum into an exact interval. Here is the limit a to b. Limit a to b, line integral a to b, f of x into d, f of x into d of x is equal to limit n tends to infinity. Ni is equal to 1 and delta x. Properties of Riemann sums. Linearity, additivity, continuity requirement. Works best for continuous functions. These properties allow simplification and combination of sums for particular practical calculations. Applications. The applications of Riemann sums. First is physics, second is economics, third is engineering, and fourth is statics. In physics, we have work, distance, and energy. In economics, we have total cost and revenue. In engineering, we have electric charge fluid flow, and in statics, we have probability distributions. Accuracy and limitations of Riemann sums. Accuracy increases with larger n. Left or right sums may under or overestimate. Midpoint sums generally offer better results. Understanding limitations helps choose the approximate methods for approximation. Riemann integral. Defined as an limit of Riemann sums, provides exact area under curve. Basics for modern integration techniques. The Riemann integral formalizes the concept of accumulation in a rigorous mathematical framework. Comparison table. Here is the type, formula, estimation, and accuracy. In type, we have left, right, and midpoint. In formula, we have ln, rn, and mn. In estimation, we have under, over, balanced. In accuracy, we have moderate, moderate, and high. Comparison guides selection of the most suitable sums for practical problems. Real world example. Velocity time graph of a car. Each rectangle represents distance traveled in a small interval. Summing rectangles approximate total distance. Riemann sums provide a practical tool for approximating real world integrals where exact calculation is difficult. Riemann sums. What is a summary? Summary of Riemann sums. Riemann sums approximate area under curves. Increasing n give rise to some approaches exact integral. Fundamental for understanding integral calculus. This cannot discrete computations to continuous mathematical concepts. Conclusion. Riemann sums link discrete summations and continuous integrations. They form the foundation of modern calculus. Thank you for your attention. This concludes the seminar. Riemann sums are essential for both theoretical and applied mathematics. The under, course outcomes are understand the concept of Riemann sums as a method to approximate the area under a curve. Explain how the definite integral is defined as the limit of Riemann sums. Compute left, right, and midpoint Riemann sums for giving functions and intervals. Analyze how increasing the number of subintervals improves the accuracy of approximation. Riemann sums. This is a quote. Riemann sums teach us that even infinite change can be understood only small piece at a time, inspired by Bernhard Riemann. Thank you.